this unit, we're going to study similar figures. In this lesson, we'll be looking at similar triangles. Okay, everybody, in this lesson we're going to take a look at similar triangles. Okay, so prior to this we were looking kind of in general at similar shapes. Now we're going to really focus our attention on just triangles here. So remember that all interior angles of a triangle have to add up to 180 degrees. Okay, similar polygons will have corresponding angles that have equal measurements, okay, because they're the same shape. So if we have two similar triangles here, they're going to have the same angles, okay, the same set of angles there. And similar polygons will also have corresponding sides that are proportional. In other words, we use the same scale factor to go from one side in a triangle to the corresponding side in another triangle. Now, because we know that all three angles in a triangle add up to 180, if you know two of the angles, you can always find the third by subtracting the two that you know from 180. Okay, so if I've got like A, B, C add up to 180, and if I know A and B, I can figure out what C is by just going 180 minus those two. Now, if it's a right angle triangle, you got a slightly better position there because you know that one of the angles is already 90. So if you only know one other angle, then it's easy to find the missing one here. So if it's not a right angle triangle and you know two angles, you just go 180 minus the x minus the y to get the missing one. But if you know that one angle is 90, and in a right angle triangle you will know that, then to get the second one, it's just 180 minus 90 minus x. So I already have that little bit of information here. So you only need to know one other angle in a right angle triangle to find all three. Okay, so remember, similar figures, including triangles, are those that have equal angle measurements. And that means that two right triangles are similar if they share one acute angle. So we know that right angle triangles are both going to have a 90 degree somewhere in there, and as long as one other angle is shared between the two of them, we know that the third one also is. Okay, hopefully that's enough. Let's take a look at some questions here. Okay, so when this question says, consider the two triangles below. Okay, so ABC, XYZ. Given that angle A is 28 degrees, and I had to write that in, it didn't print out here, and angle X is 28 degrees, prove that the two triangles are similar by showing that all three corresponding angles are equal. Okay, well, we've already been given that these two angles are the same. Now, I know, because of the way this is drawn here, that where that little square is, that's going to be 90 degrees. Okay, well, if I want to figure out what this angle C is, angle C is going to be 180 degrees minus 90 degrees, minus the 28. Okay, well, 180 minus 90 minus 28. Okay, I get 62, so angle C is 62 degrees. Well, Z, I'm going to get the same way. I'm going to take 180, the sum, minus the 90, the right angle, minus that 28 that I know, and what I'm left with should be the same. And again, if I do that in my calculator, I'm going to get 62 degrees. Now, because all the angles here are equal, I know that triangle ABC is similar to triangle XYZ. And I got to be careful to put them in the right order. Angle A and X are the same size. Angle B and Y are both the 90 degrees, or the right angles. And angle C and Z are both 62. Now, our next question, and they printed on two separate pages here, so hold on. Circle the triangles that are similar to each other. Okay, so here's my set here. I'm going to pull this up just a little bit. Okay, that's a little better. So what I'm looking for here are triangles that share. Now, these are all right angle triangles, so that's first of all, it's important to note that. Now what I'm looking for are triangles that share that extra acute angle here. So for example, I've got a 73 degree here. I'm looking for another triangle, and there it is, that shares a 73 degrees here. So I'm going to circle those two. So those two triangles would be similar, because if they both have a 90 degree in them and they both have it a 73, that third angle there in both of these cases is going to be the same, and in this particular case it's going to be 17. which actually means if this is 17 degrees and this is 17 degrees, well, look at this. This triangle right here has also got a 17-degree angle in it. Now, if that's 17 degrees, let's subtract that from 90 and 180. That's going to give me 73 degrees. So that triangle is also similar to the ones that I've circled. And in fact, if that's 17, again, that's going to be 73 right there. This one is also similar. But because this is 71, if this is 71, and I take 71 and 90 away from 180, that's going to leave me with 19 degrees. And for this last one, if we take 90 degrees and 18 degrees away from 180, we're going to be left with 72 degrees. So these angles for both these triangles are different. All four of these triangles are going to be similar to each other. Now one more, and this one didn't print well here, but in the diagram below, triangle ABC is similar to triangle XYZ. So if angle C is equal to 64 degrees, I'm going to label all the other missing angles here. Well, okay, when I look at my labels here, I know that angle C and Z are in the same location in the name, so I know that Z is going to be the same. It's going to be 64 degrees. Now, to figure out what A is, angle A is going to be 180 minus 90 minus the extra angle that I've got there, the 64. So 180 minus 90 minus 64, and I'm left with 26. So angle A is 26 degrees. And then because A and B are in the same location, when we listed the two similar triangles here, I know that X is also 26 degrees. I know that. I don't have to do any of the calculation here. I already know that they're going to be the same because those two triangles are similar.